Hello, geometry students, and welcome to the first video for lesson 3.3 covering rotations. This is going to be the last of your rigid motions. So we've done reflections, we've done translations, and now we're doing rotations. Rotations, fancy word for rotations, or not fancy, but the layman's term for rotations is a turn. So we're going to do some turning of figures today, right? But it will be a rigid motion. So again, when you do it, your figure will stay congruent. It'll preserve length. It'll preserve angle measure, so your beginning figure, your pre-image, and your image will be the same, just oriented a different way, turned, if you will. All right, so example 1 here says, draw a rotated image. Can you perform a 75 degrees rotation of triangle X, Y, Z about point P? So you would, if you did this by hand, you need a protractor. Okay, so remember the protractor is this thing, right? It has all the degrees on it. Has that hole there for the vertex, right? So I'm going to try to walk you through it virtually, right? It's going to be difficult, so I'm not going to use a protractor on the screen, but I'll talk to you about it. Now, when it says 75 degrees, notice it doesn't give a direction. We're going to go counterclockwise. Counterclockwise. So unless they tell you otherwise, you are to assume you go counterclockwise. Counterclockwise is this way. It's against the clock. Okay? So when we rotate this thing, let's start with I guess we'll start with Y because it's closest. Is that okay? I'm going to connect Y to P. Okay. Now, when I do this rotation, counterclockwise is going to be this direction, and I need to rotate so that this angle between Y, P, and Y prime is going to be about 75 degrees. So I'm going to draw this and erase this. This would be about 90, right? That's 90 degrees right here. So I don't want that. I want 75 degrees. I want a little bit less than that. All right. So again, I'm just freehand drawing. I think this is about 75 degrees right there. So that's a 75 degree angle. And again, the distance from Y to P has to be the same as Y prime to P. So I want to try to estimate that distance. And I'll say it's like right there. There's going to be Y prime. So that distance, those two distances are congruent, and that's a 75 degree angle. All right, so now let's do I guess X. We'll just go in order. I'll do blue. So here is X to P. Again, we're going to rotate 75 degrees. I'm saying it's about there, right? Rotate down the same length, and that's about how far X is from P. And there's X prime. And then last but not least is Z. Connect P to Z. Rotate 75 degrees this way. That's probably good, maybe. And again, I'm just estimating. Go at the same distance, and there is going to be Z prime. And now we're going to connect, and I'll use purple, X prime, Y prime, and Z prime. And again, if it's not perfect, don't sue me. I was trying my best here. But that's not bad, right? So these two figures should look congruent. That means they should look the same length and the same angle measures, okay, between the figures. And I think it does pretty good. So that's if I was to do it by hand. And again, because of Savas, we won't do much by hand, but there you go. That's what we're talking about today, rotations, okay? So now based off of this, right, let's talk about the definition of rotation. So if you're doing a rotation, notice the notation, R in parentheses, X degrees, comma, P. So X is going to be your degree measure that you're rotating, right? So it's the angle of rotation, angle, X degrees, called the angle of rotation. And P is, of course, the point that you're rotating about. It's called the center of rotation. Now, typically, it's going to be the origin for us in our coordinate plane, but it could be a different point. It could be a point on the figure. It could be a point in space, like in the previous example. Okay. So a couple of things. So first of all, if you're rotating around a point, the pre-image and the image for that point that you're rotating about is the same. So notice here that P is our rotation, so P and P prime are the same. Now, if it was a point on the figure, so say it was A and A prime would be the same. All right, so again, just be aware of that if your point is the center of rotation, it doesn't move. But then, if your point is not, if it's out in space somewhere, then two things must be true. And this is important. Number one, the distance from your point, A, to the center of rotation, P, must be the same as the distance from the image, A prime, to P. All right, so that's that congruence thing. And then the angle formed by these two segments, these two sides, must be the angle of rotation. And it's going to be counterclockwise unless noted. So again, it's going to be a rigid motion because it preserves length and angle measure. And again, note that a rotation is counterclockwise. So there we go. So that's your definition of rotation in general. Okay, so now what about the coordinate plane? Well, here, okay, here are some rules involving the coordinate plane and rotations. All right, so this is the point A. It's at 1, 2. All right. What happens if we go 90 degrees counterclockwise about the origin? Well, again, 90 degrees counterclockwise is going to be this way, to your left. And if I make this a 90-degree angle, it'll be about there, right? And if I go about the same distance out, there we go. Notice where A prime ends up. So if I go 90 degrees, right angle, 90 degrees counterclockwise, notice that A prime here ends up at -2, 1. It's counting by halves, so be aware of that, right? Each of these is a half. So notice here that when you do a 90-degree counterclockwise rotation, notice what happens to your coordinates. The x, the 1, goes second, and the y, the 2, goes first, and it became opposite. So notice here, right? Now, what if I take that original point and go 180 degrees? So 180 degrees would be from here all the way down. So that's 90, and then 90 more, which would be 180. So there's 180 degrees, right? So if I continue this, make that about the same length. There we go. There would be A prime. And here, A prime would be at -1, -2. So notice what happened between A and A prime. Notice the x and y stayed the same, right? 1, 2, 1, 2. But they became opposite of what they were. So now it's -1, -2. And again, reflects in that formula there. Okay, what if I take the original point and go 270 counterclockwise? So that would be 90, 180, and then 90 more. Sure. And there I go. There would be A prime at 2, -1. So when I go 270 degrees, notice that the the y comes first, and now the x goes second and turns opposite to match that. Now, instead of going 270 counterclockwise, if you see the angle formed here between the A and A prime, this is also 90 degrees clockwise. So 270 counterclockwise is the same as 90 clockwise. So keep that in mind, right, as we go through that. All right, now one thing to note here, I'll highlight this, is that these negative signs are not negative signs, they're opposite signs, right? So if you see the negative sign, it means opposite. Opposite. Okay, so not necessarily negative, it just means opposite. So let me see if I can log into Savas real fast, and we'll get this going so you can see the different rotations and how it changes. All right, so if we take a look at this exploration in Savas, so notice here, I can change the angle of rotation right here. So notice A, when I go 90 degrees, there we go, right, -2, 1. B, or sorry, 180 degrees, down here, -1, -2. I'm going to do 270, there you go, 2, -1. And notice here, see that 270? Notice that 90-degree wedge right there? You could go 90 degrees clockwise. All right? Really pretty lucky that we have this nice software to show these examples. Okay? All right, so let's take a look here at our next problem then. So it says here we have ABCD, looks like a kite. It's not a kite, but looks like a kite kind of. And it says we want to rotate this 90 degrees about the origin. Okay, so there's a couple things you could do, right? You could try to figure it out on the coordinate plane, or you can use the rule, right? Now remember, we're going 90 degrees counterclockwise. So the rule here is that any point x, y is going to become, well, your y is going to come first and become opposite. Your x is going to go second and stay the same. So if we look at A's coordinates, right? So A's coordinates are 3, 5. A prime will become, well, the 3 goes last, the 5 comes first and becomes opposite. -5, 3. B is at 1, 7. So B prime, y comes first, opposite, x goes second, -7, 1. C is at -2, 4. For C prime, y comes first, becomes opposite, x goes second. Now here, notice, I know in the formula the x doesn't have a negative sign, so you keep it the same. Doesn't mean negative, it means keep the same. So the -2 stays the -2, keep it the same. And then D at 2, -1 becomes D prime, bring the y forward to make it opposite, -1 turns positive, x goes second, and it stays 2. And now we graph this. So this is a coordinate by coordinate analyzation, and now we graph. -5, 3. There's A prime. -7, 1. There's B prime. -4, -2 is C prime, and 1, 2 is D prime. And we connect A prime, B prime, C prime, D prime, and there would be your final answer. And again, as you're doing this, you should kind of look at your figure and say, does it look the same as the original one, just turned? And I would say yes. Okay. Notice also that A, so if we talk about quadrants, this is the first quadrant, second quadrant, third quadrant, and fourth quadrant of the coordinate plane. Notice that A and B are in the first quadrant, so it moved to the second quadrant, 90 degrees. C was in 2, so it moves to 3. D was in 4, so it moves to 1. So 90 degrees is one quadrant. All right, so I'm going to stop there, and we'll do video 2 coming up right next.